Hi, we are going to talk about the 5 types of chemical reactions. To begin with, we have what's called synthesis. Now sometimes you'll also see this called combination. Synthesis combination, it elicits the actual meaning very easily. You have 2 or more reactants that come together to form one product. So the key is you see that one product. So notice we have magnesium plus oxygen forms magnesium oxide, synthesizes, combines into magnesium oxide. Next, decomposition. This also brings to mind what the reaction looks like. Decomposition, decomposing, breaking apart. This is going to be one reactant, so the key is you're looking for one, breaks into 2 or more products. So we have a calcium carbonate is going to form calcium oxide and carbon dioxide, 2 products. So this calcium carbonate decomposes, decomposition reaction. Next, combustion. Okay, now technically combustion is anything that burns in oxygen. So I want to show you something, and I picked this purposefully because it's a little tricky. Look at this, magnesium plus oxygen. That technically is both a synthesis and a combustion. So a metal plus oxygen is combustion. Now here's the classic when we think combustion. It's a hydrocarbon, and a hydrocarbon is any molecule with carbon and hydrogen in it. Now you could have something else in it. You could have oxygen, sulfur, nitrogen. The key is that you see carbon and hydrogen. That's a hydrocarbon. So a hydrocarbon plus oxygen, when I burn this in oxygen, always produces water and CO2. You want to have that memorized because you will see problems that will say, let's see, propane combusts. That's all it will give you. And you are expected to write that complete chemical equation, knowing, all right, propane, I can figure that out, C3H8, combust, add oxygen, and the 2 products are CO2 and water. You'll want to have that memorized. Next, single replacement reactions. Okay, watch the metals. This is like when you have somebody on TV that have the little walnut shells with peas, and they move the walnut shells around and you're trying to follow the pea. Okay, here you're following the metals. So look at what we have here. We've got copper plus a silver nitrate yields 2 moles of silver and 1 mole of the copper 2 nitrate. Look at the metals. So here's copper, copper. Look at the silver, silver, silver. What do you notice? This copper is by itself elemental form. Here it's in a compound. The silver on the reactant side is in the compound, and on the product side is by itself. The copper and the silver switch places. These change places. So a single replacement, you're going to have one metal plus a compound, and the metals switch so that the metal that was in the compound is now by itself and the copper is on the compound. Now to predict this, there is something called an activity series. Activity series. And here's what you need to know. The most reactive metal will replace the least reactive metal. And on the activity series, it will indicate one way or another, sometimes just with an arrow, which side is the most reactive. If I were looking at an activity series, this is what I would observe. I would see copper above silver, and there would be an arrow going up for reactivity, indicating that the higher on the scale you go, the more reactive. That tells me that copper will trump, it will kick off that silver and be in the compound. Silver will be by itself in elemental form. So this right here is a great example of a single replacement reaction. Okay, the last one. This is going to be the double replacement reaction, and it's the same deal. Watch the metals, okay? So I have potassium iodide plus lead 2 nitrate yields potassium nitrate and lead 2 iodide. Let's look at the metals. We have potassium and lead, potassium and lead. Check it out. Potassium is attached to the iodide, lead's attached to the nitrate. They switch places, switch places. Now the potassium's with the nitrate. That's where the lead had been. And now the lead is with the iodide. That's where the potassium had been. So in a double replacement reaction, you have two compounds and the metals switch places. Those metals switch places. This right here is also an example of a precipitate reaction because you have a solid that's formed